Howdy and welcome back to the shop. Today we're going to be working on the old Onan generator a little bit more. And as you can see, I've got things put back on here. My wife seems to think that sometimes my wrenches only work in one direction, and that's the taking apart direction instead of the putting together direction. But, that's wives for you. So let me take it back apart up here and we'll kind of look and see what's going on. Let me move you in a little closer. So you can see, sorta, there's my throttle linkage. I've got it routed. I took a nice dull beaver and cut a hole through the sheet metal here for the throttle linkage to have a nice, reasonably straight shot. Of course, you got to deal with what you got. So the idle stop position, low idle, which these machines never really hit low idle, they never hit idle. But it's the idle stop is actually bottomed out on the actuator rather than up here at the idle set screw. Of course, you can't see up in there. And I think I discussed this in an earlier video. I don't like things like idle stops and things like that to be controlling the stop on the governor. I just don't like that. And this thing has a lot more spring tension down than it has electromotive force pushing up, magnetic force pushing up. So I'm not so concerned with it going wide open and hurting anything as I was when the machine shuts off. When you hit the kill switch, it kills the power to the stepper or the actuator, and it snaps shut. It doesn't really snap wide open very often. So that's kind of a consideration, or at least it was for me. And I've kind of tidied things up in here. A few clamps here and a few clamps there. I don't want my spark plug wires to be flopping around inside of there like they were from the factory. There's just too much business going on right here right now. So I kind of tidied this stuff up. Same thing goes for my mag pickup. There's the flywheel there. There's the MPU. And there's the bracket that we made. So I tidied all this stuff up so that there's very little chance of anything getting into these wires. And we're also not blocking any airflow. That was one of my big considerations when I was building all of this stuff, was I did not want to block airflow because this is air cooled. You don't want to pinch the radiator hoses off on your car. You don't want to block airflow on an air cooled engine. So the lead for my mag pickup, this is the original hole that was used to reach in and adjust the governor. I just reused that hole. I will get some little grommets to go in there and protect that. This here goes over the stepper, and these are just 2-pin weather pack connectors. You can buy kits like this all day long through Scamazon and Fleabay. Has almost everything that you need to be frustrated. So, that's just what I did. I don't like butt splices. I don't like splices at all. I like actually using the proper connectors. And, a little bit of heat shrink tube and things of that nature makes things look pretty. So here we're connected to the speed control unit, the governor. Now, I've just got this temporary together because, I'm going to mount this permanently. I've got what I think is a Chinese clone of a deep sea control on the way. Deep Sea, I called them the other day, and they're out of stock. Can't get none for, anyway, out of stock on Deep Sea stuff. So I got on Fleabay or Scamazon or one of the disreputable sellers like that and found the device that I was looking for at an unbelievably low price. So I'm assuming that I'm going to be terribly disappointed. Perhaps I won't be. But anyway, if it's a Chinese clone of a Deep Sea and the Deep Sea, if it's compatible with the real Deep Sea software, I'll be happy. I wouldn't really want to use it on a customer's rig, but I'm keeping this one, so it is what it is. So anyway, this is Belden 1075A cable. It is 2 pairs of twisted shielded conductors. And I forget what the gauge is. It's not very heavy gauge, 16, 18 gauge. Not very heavy gauge wire, but there's microamps coming through the pickup, and there's probably less than 2 amps going through the actuator, and the wire length is going to be under 5 foot. The important thing to me, and it's really not that necessary, is to have the pickup be shielded. I like shielded wiring. It just, if it's shielded and properly grounded, you're not going to have any troubles. So, it's just temporary. This will be cleaned up a little bit more. So here's the adjustments. Okay, you've got starting fuel speed ramping. We're not using that. That's for if you've got a diesel or a something that needs to be warmed up slowly, brung up slowly, things of that nature. So starting fuel speed ramping, we're not going to use that. Droop and idle, we're not going to use that. Droop is for a decelerator pedal. Idle is for idle if you're using a throttle. This right here is just a remote throttle hookup. You just put think of a loader or a forklift or something of that nature. That's just to basically decelerate it and accelerate it. Think of a Singer sewing machine foot feed. You stomp it on a Singer sewing machine, on your mama's sewing machine. Whoop, I hit the camera. You stomp the pedal and the resistance goes towards 0. You let off the pedal and resistance goes towards infinity. That's what goes right here. Just a regular old pot resistor. Droop is just an on-off switch, kind of a low idle type setup. I can't think of a specific instance where you would use that, but that's what that's for. Maybe you could put a switch in there, like on a liquid-cooled machine or even an air-cooled machine, to where you could idle it down until the temperature reached a certain point, like 140 degrees. You don't want your forklift to run at wide open unless the engine's 140 degrees. So that's what all this stuff here is. Now, I'm not even going to talk about the dip switches that are down in here. That's none of my concern right now. They're right here. Speed is what it says it is. It is the actual RPM of the motor, the prime mover, that is. So that's where you adjust your speed, and your gain and your stability are adjusted here. And we're going to talk about that here in just a mere matter of moments. So let's get into a little bit of theory here. So here's what we know. We've got a 4-pole rotor. So that needs to turn at 1800 RPM. And we have got a 96 tooth flywheel. So with those 3 things, we can calculate what our frequency is going to be on our speed sensor. And what just happened to the camera? Oh dear, oh dear. So join me in the next episode and we will start talking about governor theory. We're going to cut her off for here because I think my camera battery is just about to go kaput. So, till we meet again, y'all drive safe, watch for deer.